I'm holding in my hand a wooden block. The mass of this block is 130 grams. Setting this block on the board reveals nothing startling. There are two forces acting on the block. We've got the weight force acting down and the normal force from the board acting on the block pointing upwards. If we add those two together, they add up to 0. The block's at rest, so it remains at rest. It does not accelerate. I could accelerate this block with my hands and it slides across the board, but it stops moving. What force is responsible for causing the block to accelerate in that direction, causing the motion to stop? So let's do some investigations. I'm going to add a few extra masses to this block. I have a string attached to the block, and I can use this spring scale to pull the string which pulls the block. You'll notice that I can pull the block, and the block doesn't move. I'm pulling with a force of 4 newtons, yet the block doesn't move. So what force is responsible for holding the block in place? You'll notice that I was able to get the force all the way up to about 5 newtons. Then the block started moving and the needle immediately dropped. Let's see if we can repeat that. So now I'm pulling with a constant velocity and the force is about 3 newtons. Let's see what happens if we double the normal force. So I've got 2 masses already, let me add 2 more. And of course we have the mass of the block, so to double it, we need to add 130 grams because that's the mass of the block. And let's repeat this and see what happens to the numbers. Let's try that again. Let's try another experiment. Here's a wooden surface. I'm going to take this wooden surface, set that on the wooden board. We'll stack our 2 wooden blocks back on. The normal force is exactly the same as it was in the first experiment. Let's see what we get. Things behave a little differently than what's described in the textbook. Your instructor will discuss that in more depth. I have one last experiment to try with you. I'm going to change the surface which is interacting, the 2 surfaces. So the first time it was a wood surface on a wood surface. This time we'll use the exact same materials, but I've added some felt pieces down here. So I've changed the materials that are interacting. Let's see what happens. What can you tell me about the coefficient of static friction for this surface on wood compared to the coefficient of kinetic friction for this surface on wood? What can you tell me about the differences between those 2 coefficients of friction between here on wood and here on wood?